Hey everyone, Dr. Block here, looking to revisit skills necessary for success in our unit on RedOx. So we're going to go over the practice unit exam. Here we go. Alright, so let's begin. Question number 1. What is the oxidation number of sulfur in N2S2O3? Well, let's go ahead and write that down here to start our inspection. Na2S2O3. Now, if you do recall from class, if nothing is written here, we have to assume that the entire molecule's charge, the net charge, is 0. So let's go ahead and start breaking this thing down to inspect it. Now the net charge at the end is going to be equal to 0. Alright, let's first look at oxygen. There was a rule that oxygen must be -2 unless it's combined with another element making it a peroxide. So let's put -2 here. But we have 3 of them, giving us a total of -6. Now sodiums are going to be a +1. Let me show you why. Take a look at our periodic table and we will see no other choice, but right here, sodium must be +1. Let's get this out of the way now. So if sodium is +1, and we have 2 of them, we have +2. Now what must we combine with +2 and -6 to get a net charge of 0? +4. Now that +4 goes with the sulfur, but we have 2 sulfurs. So each sulfur must be a +2. Your choice. Number 2. Number 2. Given the reaction that occurs in an electrochemical cell, it's asking during this reaction the oxidation number of zinc changes from what to what. So in other words, the zinc that is right here, the solid zinc that's on the reactant side, how does it compare to the zinc that is combined with sulfate, so zinc sulfate, on the product side? So let's write this down. Zinc solid, well, it's going to become part of zinc SO4. That's aqueous. Now what is happening? Now we do know that any uncombined element is going to have an oxidation number of 0 to begin with. Already we're looking at these 2 choices. Now what's happening on this side? Well, that's a polyatomic ion, and a polyatomic ion has assigned to it a charge. Let's see what polyatomic ion this one is. There it is. SO4 -2. So -2, remember that. So -2 is related to all of this. So if this is -2, this must be +2. So what is happening? The zinc is going from, it's going from 0 to +2. Choice 1. Alright, number 3. In a redox reaction, the total number of electrons lost must equal the total number of electrons gained. Listen, that goes hand in hand with what we've talked about when it comes to law of conservation of energy, even law of conservation of mass. Even though the mass of an electron is barely anything, we even ignore it. But we've talked about law of conservation of mass, law of conservation of charge. Just goes along with that. Number 3. Oh, and law of conservation of energy. So charge, energy, mass, we have to be conserved. Number 4, the transfer of which particle is required for a redox reaction? Well, we did say Leo says Ger, and one is loss of electrons is oxidation, while the other is gain of electrons is reduction. What do they both have in common? Electrons. Alright, number 5, in an oxidation-reduction reaction, reduction is defined as, well, Leo is loss of electrons is oxidation, and Ger is gain of electrons is reduction. Here's an example, a 0 charge with 2 electrons becomes a -2, our answer must be choice number 4. Number 6. When a lithium atom forms a lithium plus ion, the lithium atom will do what? Well, it starts out as a lithium atom, so its oxidation number must be 0. And it is becoming a lithium +1 ion. So what must be occurring to go from 0 to +1? Well, in order for that to happen, you must lose a negative charge. So let's separate out that negative charge by putting it on the product side. You must lose an electron. And that happens to match choice number, not 1, it's not proton. Gain electron, no. Lose a proton, no. Lose an electron. 7. Which half reaction equation represents the reduction of an iron 2 ion? Iron 2 ion. Well, if it says iron 2, it's telling you that you must have the iron 2 plus version. There is also an iron 3 plus, but that's not the one we're talking about. We're talking about the iron 2 ion. And the reduction. The reduction means that it must be going down. The charge must be going down to 0. And how do we get to 0? We have a positive charge. We must be acquiring a negative charge. How many? Well, 2 in fact. 2 electrons. Now, which one does this match? Okay, there's the iron 2, but it is not gaining an electron. That says iron 3. This one just says iron 2, iron with the iron 2 on the product side cannot be. This one is showing the iron 2 right here with gaining 2 electrons to become iron with an oxidation number of 0. Choice 2. Number 8. Given the lead-acid battery reaction, which electron equation represents the half reaction for the oxidation that occurs? Oxidation. Red cat, inox, Leo says grr. Oxidation. Leo. That's oxidation, loss of electrons. Losing electrons. We're looking for the number to go up. Now, let's enlarge this some so we could assign the oxidation numbers, because this one gets a little bit complex. The oxidation number for lead here is 0. Lead here is 0. The oxidation number for oxygen is -2, but we have 2 of them, so that would be a -4 total. So this lead must be a +4. And here we have H2SO4. The hydrogen must be a +1. That looks ugly. That's a +1. While this is a -2. You could confirm that by looking at the periodic table. Now that's our reactant side. Let's look at the other side. We have a -2 with the oxygen, a +1. The SO4 as a whole is a -2, and for that matter, that's what I did here. Sorry, I jumped that step. So, -2, this must be a +2. We have a very unique situation here. Here we have lead going from a 0 to a +2. Now that's one of them. You see, we have 2 leads. One of the leads goes from 0 to +2. And this other lead goes from a +4 and again to +2. Now we're looking for oxidation. Which one represents oxidation? Reduction, the number would be going down. And that would be this one, +4 to -2. That would be reduction. But we need oxidation. So we have to show lead at the 0 climbing to a +2. Now how would it do that? It would have to lose 2 electrons. Now which one represents that? I see lead here as the 0. lead here, and it has to move to the +2. This one's showing to the +4. This one's showing that it's moving to the +2 and losing 2 electrons. Sorry, it's losing 2 electrons. Question number 9. In this reaction, we are looking for the oxidizing agent. Oxidizing agent. That must be a substance on the product side that is able to oxidize the other. So if it's able to oxidize the other substance, it must be willing to take its electrons. It must be the substance that is being reduced. Well, let's start assigning these. Here we have oxygen, that's a 0. Here we have hydrogen, it has to be a +1. And if that hydrogen is a +1, the sulfur is a -2. Now on the right hand side, the oxygen is a -2 here. So the sulfur must become a +4. Now just for completeness sake, this hydrogen is a +1 and the oxygen is a -2. So in both cases the oxygens are moving to -2. And the hydrogen is going from +1 right here to a +1 here. We would actually call that a spectator ion because it's not changing. Let's actually just cross it out so that it does not impact us whatsoever. So what is happening to the sulfur? The sulfur on the left side is going from a -2 to, on the right side, a +4. Its number is significantly increasing. The sulfur is oxidizing. I'll put an O on top, which means it must be behaving as a reducing agent. As opposed to the oxygen is moving from a 0 to a -2. The number is going down. The oxygen is being reduced. Therefore, it must be the oxidizing agent because it helps the other substance do its job. So, in this case, the oxidizing agent is what? It is the oxygen. Alright, number 10. In a redox reaction, the reducing agent. Now, please refer back to the last slide because on that last slide, we recognize the reducing agent must be the substance on the reactant side that is being oxidized. Okay, because you have to realize once again, if the substance is being oxidized, it must be losing its electrons. And if it's losing its electrons, it must be losing its electrons to the substance that is being reduced. So therefore, it is considered the reducing agent. So back to the question, in a redox reaction, the reducing agent will do what? Well, it will lose electrons and be oxidized. Okay, number 11. Which balanced equation represents a redox reaction? Now remember, a redox reaction, we are going to be transferring electrons, so those oxidation numbers must change. Quick inspection shows me number 2 is a double replacement. Pause it if you need to, but all double replacements, oxidation numbers remain the same on the reactant and product side. Number 3 shows me I have a negative ion here, a positive ion here, and if you work out the oxidation numbers, the bromine would have a negative ion, negative oxidation number, and lithium a positive, 1 each. Oxidation numbers are not changing. And number 4, we have a +2 here for the calcium. Well, calcium here in this position becomes a +2 because the sulfate is a -2. In fact, right here it tells you it is. And our chart with the polyatomic ions does as well. Taking a look at our last choice, chlorine has an oxidation number of 0 on the right. And on the left here it has to be a -1. So right then and there must be your answer.